start with our first speaker. So yeah, as we have continued with the theme of AI, we have Wladek Miner, who's now, is it now emeritus already, professor? Not yet, not yet. So close. At the University of Virginia, and his background is in physics, but yeah, he's done a lot of other things over the years, and he's now talking about CheckMyBlob, I believe, which is an AI tool that tries to find you whatever is in your unexplained blob in electron density. So please take the stage.
This introduction. I am not emeritus yet. In 1.5 years, I am taking early retirement in the age of 80. So I will talk about AI. I will mention CheckMyBlob, but not only, but CheckMyBlob will be a part of that. I am supposed to show, should disclose that I am making money on site, but really it's more formal than reality. So first thing, you see that are we in digital age? Yes and no. Still, we are doing sharing results, we are doing mainly what has been done 400 years ago during Gutenberg time, except that now the process of production of the paper is longer than it used to be 400 years ago. And I would like to advocate to change to something else, to have review from a short report and describing what cannot be in the digital form, but everything should be in digital form. And unfortunately now, the PDB report is treated by 80 or 90% of depositors as a nuisance which they have to do in order to get publication in the paper. Yes, they do not pay any attention to what is in CIF file or what is in PDB file. And sometimes I have impression that PDB-E or PDB-J or RCSB does not pay attention to. And I have to harass them, yes, which I will show in a moment. So you see that digital form, it's not only in structural biology. I spent 2 months in Japan last spring, and we went to Naruto Straits, and it's fantastic vortexes you have here, but there is also Otsuka Museum of Art. And it's very special museum because it does not have a single original art. Everything is digital. So you see that you can see the Last Supper as in Milan now, but you also on the other side, you may see the Last Supper as it looked before renovation. And you may see Leonardo in one hall from various museums, and I am showing from Krakow and from Louvre in the same, next to each other. And you can also, if you are in the mood to marry somebody in the one of the Vatican chapels, you can do that in this museum for a very small fraction of the money which you would have to pay for a ticket. So you see that you have fantastic opportunity to look at the art from digital point of view. Now, PDB. I would like to say that despite of all complaints about PDB, this is the highest quality large resource in the world. Really, the highest quality. Yes, it does not mean that it's good. Yes, it means that others are worse. Yes, it's very, very important distinction. And our goal is to make that better. Yes, our all goal, not my goal. And you see that there is, here you have a number of structures which got Nobel Prize. So you see that this is the unique resource which can be connected to largest number of Nobel Prize for anything. Now, AlphaFold 2 and AlphaFold 3, there was many discussion about that. But you see that maybe I missed something, but nobody said one thing, that it changed crystallography. Not only crystallography, it changed structural biology. Because SAT and MAT became almost obsolete. Yes, and here it's an example of Tom Terwilliger paper when he took 50 structures and used AlphaFold and solved 40 bimolecular replacement. And I took this 10, which he didn't solve, and solved 8. Yes, we even didn't bother to publish it. Yes, it was so insignificant in some sense that we didn't bother to publish it. So now, PDB again, uploads and downloads. Yes, that you have here uploads of X-ray, which is blue, cryo-EM, and NMR. And you have also this curve, which is the number of downloads. Now, the scale of this uploads is 1 year. So my question to you, what is the scale of downloads? Can anybody guess? You see, we have over 100 people. Somebody should try to guess. Sorry? 0.1 of what? So 1 month, yes? Okay. So it's clear that nobody review my last paper. 2 minutes. So 2 minutes. 2 minutes downloads. So it shows very, yes, and this is the, this figure which has the description of, and it's 1 year more than on the previous, because previous, the process takes some time, and this is online. This picture is also online. And we should have all figures online somewhere. Yes, and it shows that it's still growing. It's still growing. 2 minutes. So now realize that every mistake in the ligand, in the metal, has tremendous ripple effect. Yes? So we really have to look at that. Now, the next question. Should we trust the model or check the map too? So you see that this is the example where you have clear blob, which is a water, and there is nothing here. Yes, in the model, there is no, and you see that there was another paper about the same structure, and they wrote, you can look at that, it's quite important, taking into account that it's related to COVID. Yes, that we know that in some X-ray structure of the ligand, free blah, 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 obtained at 100 Kelvin, this potentially critical water molecule is absent. It's not absent. Authors didn't look at the map. They look at the model. Yes, unfortunately, in PDB redo, this model is absent as well. Yes, and Tassos is author of the program who is adding quarters. Okay, so you see, for a number of years, we wrote number of papers, and I'm putting here only journal covers of with these papers which got journal cover, which some people see as a PDB harassment. But these are the problems of which you have in PDB. Now, protein diffraction, RMC. Yes, the place which you can upload the raw data. This is the only place, to my knowledge, which is checking metadata, because we are trying to reprocess every data set which is uploaded. Now, there is statement that data should be fairness. What does it mean? Findable, accessible, interoperable, and reusable. So what is the reality? This is when you are looking on IRC versus other resources, and how they represented in PDB, RCSB PDB, and PDBE. And it's clearly that these resources do not talk to each other. Yes, and you have here the DOI, which are going nowhere. Yes, in both cases. So this is the reality. Why it's important? The question is, what drives our decision? Yes? I know that I am right, yes? Usually this drives our decision, especially decision of some PIs who knows that they are right. They do not want to listen to what people in the lab have to say. But the problem is that there is data versus opinion. If we have the data, let's look at the data. If all we have are opinions, let's go with mine. Yes? So we have to look in the data. Now, it is supposed to be AI talk. So you see that AI is some process. It's data collection, data curation, data analysis, data exploration, and actionable insight. And all 4 steps are easy. Yes, anybody can do that. Data curation is a problem. Yes, we have to have training data set. And you see, what we should have also, we should have problem-solving approach. Not the structure, but problem-solving approach. And this is the example of the structure, which is albumin with dexamethasone. And why we published that? We solved that a long time ago during structural genomics, and we didn't bother to deposit that even because we didn't finish refinement. But I had over 470 deposits. So at some point, my lab lost incentive to deposit. And you see, labs were closed. I was walking with my wife and looked at the phone and found that Boris Johnson announced that dexamethasone is the only thing which work with, for COVID, early stage. So I call Mateusz Czub, who is here, who was a graduate student, and he couldn't be in the lab as well. And I asked him, could you please check if we have dexamethasone in the our database of reagents? And 5 minutes later, he called me back and said, we have dexamethasone. It was used one, we have a structure with albumin. It was not refined. So I said, okay, to refine that. And next day he called, it's refined. We deposited the structure immediately. And we started to write a paper. But you see, in that time, we could write a paper, we could have paper accepted without any additional studies, but we look at the internet and look at the data from Wuhan, the only medical data which we can find. And we found that the albumin, that if you had albumin above 4, you survived. Yes, we submitted the data. At the beginning, we got 1 positive review and 1 negative, in that sense that reviewer said you should publish the paper, but without this medical crap. But fortunately, Ted Baker was an editor, and he went to another reviewer who was in the same time crystallographer and medical doctor, and we got positive. And you see that, and it was later confirmed that the level of albumin above 4 make you alive. There's nobody who had albumin above 4 died. Okay, so we have to look, when we have structure, we have to look in the wider sense of that. So, because people start to deposit structures very fast, in the usual authors, we were started to talk what we can do. Yes, now when we at home. So we started to look at the structures. We made the database of all COVID-related structures, and we look at their quality, especially for ligands and metals. And these are the papers which were created by that, and 3 journal covers. And you may say, okay, you are cheating. You have a paper from 2019, and the COVID started in 2020. No, because CheckMyBlob was critical for the use. Yes, and it was published really earlier. And you see that here is the example of four structures, which we found earlier before we published the paper. And we correct. Every time we contacted the authors and asked them to make a joint deposit, redeposit the data, the structure. Yes, and we succeeded. Not always we succeed. Yes, few times I asked for a data, I didn't get data back, but it was new deposit. I think that I succeeded. I do not need one more deposit. I want structures to be correct. So this is very, very important to have in contact with structures. And you may notice that now the ORCID and email of the current author is required by PDB, and it's us. This is the biggest achievement of Commission of Biological Macromolecules of IUCR, which I am the chair. I think it's the biggest achievement. But yeah, but not everybody share my views. But you see, what is the problem, Christopher? That people do not seek. Yes, and this is the exam of the paper, which have 63 authors. And it was 7 times corrected, but still occupancy of water changes between 0.99 and 0.78, 0.96, 0.92, and so on. Look, this is all one. Yes, you are adding parameters. So you see, I would like to say, and I contacted them a few times, no response. So there is something which 45 years ago, students in physics department in Warsaw University called Minor's principle. And Minor's principle tells you that you can draw straight lines through any 3 points on the plane. So you may ask how you can draw straight lines through that. Very simple. Just use the thickness of the line as an additional parameter. Yes, and here occupancy is quite often used as a way to put wishful thinking into deposit. Yes, and there are many such problems. There is 900 zinc atoms with occupancy 0 in PDB, 136 with occupancy 0.1. Yes, and you may argue that this is possible. Unfortunately, there is 38 atoms with occupancy higher than 1. Yes, and I didn't know that when we wrote about something else in the paper in 2008 with Max Kruscht, who was in the time in my lab. Unfortunately, on a very small percentage of lucky scientists observing global chemistry in their structure will ultimately hear from the Nobel Committee. But the unlucky ones will soon find sooner or later that the validation tools will ruin their claims. So my appeal to PDB is work on the validation report, and it's quite good. Yes, it's quite good. Not for cryo-EM, but in general, it's quite good. But rerun the validation on old structures. So I would like to see the new tools for old structures. Rerun can be automatic. So now this is another thing which we are using, which is CMM, CheckMyMetal. And you see that people here, as you see, that they are putting their favorite atom, and they play with occupancy. Where is occupancy here? Oh, here, 0.39, 0.37 to get fit to the map. Yes, but it's enough that you replace zinc with sodium. You do not need to play with occupancy. So now the CheckMyMetal is checking crystallization condition, and it's looking through all metals to find the proper stuff. There is one thing, I know that my time is running. No, your time is running. And you see, reporting system, reporting about errors. Every resource have errors. And we made a system which reports for any our things. People are putting on the web what is wrong. And you have that, it cannot be removed by people. People who are working on that may fix that or not. Take into account that as of last June, I do not have any grants. I am running for distinguished professor money. So clearly, NIH does not care, or our colleagues does not care about accuracy of structures. Yes, waste of money. So now, X-ray and cryo-EM take into account that these are the resolution, average resolution of cryo-EM and X-ray. There is one cryo-EM structure which has resolution 1.1, but it's one structure. There is 136 which have resolution better than 2.5. And this is how your ligand looks at 2 angstrom and 3.4 angstrom. So Darek Brzezinski, who was in my lab, who was working on CheckMyBlob, made new CheckMyBlob with cryo-EM, and we are going to collaborate. But the problem is how to cut the blob from cryo-EM data, which have 3 angstrom, yes, which are continuous resolution. And this is the problem. And you see that we are talking about cryo-EM resolution revolution, but this is how the cryo-EM is going, is improving over years, but we're still not there. Yes. The one thing which is important, the data, it affects everything. Messy, incomplete US data hobbles pandemic response. Title from Washington Post. And one doctor said, we are flying blind. Yes. Doctors were asking me about PDB at UVA. So now, age discrimination. You see, if we are talking about, these are the deaths of people who are above 8. Yes, and this is above 65, I mean 65, 70. And we decided, because I was running data management for 4 large NIH centers, 2 minutes, yes. So I decided to look into that, and we published papers about SARS-CoV-2, and this is the competition between vaccinations, new vaccination, and mutation of the virus. Yes, we lost. Yes, the daily deaths, discussion that people are dying in some days, and some days they are not dying, and doctors were trying to do. You see, the problem was very simple. Yes, virus does not take weekends or vacation. People who enter data, they do. And they have the data when they enter the date when they enter, not the date when somebody is dying. So all these theories are great, but useless. So in the end, I was asked to write by reviewer, to write recommendation, and we put recommendation for researchers, research facilities, funding agencies, and I didn't stop, I put for governments. So they cannot say that they didn't know. Recommendation is printed, yes, in IUCR journal. And you see, the most important for all, be proactive, not reactive. Yes, so if we have errors, we have to fix them now. And I would like to really underscore the importance of artificial, of the correct data set. Yes, the difference, this is the difference between corrected data set and incorrected data set. And obviously, I would like to acknowledge all my collaborators, which we wrote in various configurations. Darek Brzezinski was in my lab, and now he is in Poland in, I think, 2 institutions. I put only 1. And over years, I had a lot of funding, but now I am, how to say, on the diet. And I have only Harrison family funds, distinguished. Thank you very much.
Right, have we got some questions? Couple of questions.
Hi, Deborah Harris from PDB. Thank you very much for the inspiring talk. You mentioned that you would like old structures to have their validation reports updated. So you will be pleased that to know that we do that. We do full archive recalculation of reports once in a while, and the next one is this spring. So yeah, that's coming. So just thank you.
Okay, great.
One other question, or is there something online? Everybody's still asleep.
Dennis.
Hello, I would use University of Southampton. So that's what I meant yesterday at the dinner speech, that AI is a great idea, and we have a lot of use. This graph that you showed was just really exciting, because what it does say is that what we do need as a community is training and education on how to read structures. So how do we improve on that one?
how we can improve on the identification of the researchers. Yes. You see, it's possible, but it's tremendous effort because people are changing institution and you have their email, you may find them, there is no response. Yes, sometimes I can tell you, I contact head of the department and I am asking, is that person still in your department? Is he alive? Is he or she alive?
In a situation where the users of the data are not crystallographers and not trained.
Yeah, this is the problem. You see that this is the problem. And I am happy that you are saying that. That the question is, who should be consumer of PDB? Yes? Biologists, not structural biologists, but biologists. And I have to say that with all my critics about PDB, Steve Berley did phenomenal job moving PDB toward resource for biologists. Yes, and it's much, much better. And you see that, in fact, when people were looking at COVID, 101 in PDB was phenomenal resource. Yes, and I have sent probably around 1,000 emails pointing the people who were asking me to this resource. So you see that it's very important that we see our errors, but also it's very, very important that we promote our achievements. Yes, and promote our achievements not to other structural biologists, but to general public. Yes, and you see that I'm quite proud that I have 5th paper, which is in print in expert opinion in drug discovery. And I am solid state physicist. Yes, and you see that the last paper is about cryo-EM. And I mean, all these papers are by invitation. And when editor called me and said, Wladek, could you write a paper about cryo-EM? And I said, Dave, I didn't solve a single structure. I do not know about anything about cryo-EM. And the answer was, that's great. We are looking from the point of view of X-ray person. Yes? You see, as I am saying, I am solid state physicist, and I was hired in biology at Purdue, and this was spousal hire. Yes, we are scientists. We are not structural biologists. We are not crystallographers. We are scientists. And we should train scientists. This is what I said yesterday. I do not remember if it was yesterday or the previous day.
Thank you very much, Wladek. That was a lot of insight.